Not going to be in the book today. We'll actually start using the book tomorrow, but I could not get in tomorrow to get the books. All the slots were filled up. That's why we got them today. Now, one of the interesting things about these textbooks is if you look on the back cover, there's a, right at the top, it talks about calcchat.com. It's nice because it comes with the book, and if you need to see something worked out, I mean, we'll always answer questions in here and stuff that you have. But if you're really stuck on something, you can pull that up and it can show the different problems kind of worked out in steps. It kind of give you some help and things like that. It doesn't necessarily show every single problem, but you know, if you have to work number 13, maybe it showed number 12 to kind of help you out a little bit, things like that. And it has like an online discussion, things like that. And that's one of the reasons we've kept these books for so long, right? Because that part's still included in it. And it does make it kind of nice for that piece there, okay? Other than that, we're going to start working with just some quick function value stuff today, so your assignment will actually be on a worksheet. But the second part of your homework will be go through sections P1 through P3. You don't need to work anything. We just look through, and everything in there should sound familiar. I'm not saying you remember everything to a T, but it's like, okay, I remember doing that at some point in the last couple years, okay? If something is really just out of whack and you don't remember any of it, then that's something you want to bring back and talk to me about so we can make sure that we go over up here real quick. But everything else should sound familiar. You just want to look through P1 to P3. Sometimes it might be easier to just look at the exercises in there. Just, okay, I remember doing something like that. Like one of the things in there is transformations. You remember shifting a graph up, down, left, or right? Now, if you don't remember exactly how to shift it, that's fine, but you do remember doing it. That's what I'm looking for. Remember doing something like that. That's going to be what the key is. That's all I want you to do on there. Nothing to work out. Okay? So we're going to look at some function values here for review. This should look familiar. We're going to get a couple new looks here. Let's see how you remember this. You should remember working with functions. Let's make something up here. Let's go like just a function 3x minus 2. So remember, functions were usually f of x. Sometimes they were g of x, p of x, whatever, but usually f was the most common, f for function. Okay, but you've seen different letters up there. So if I wanted to find f of 2, what did that mean that I did?
Replace x with x.
All right, replace the x with a 2. So 3 times 2 minus 2. And we got 4, right? That look good? Okay. You should remember doing things like putting a variable in. It didn't matter what the variable was. But if I was going to find f of a, then a is replaced in the x. Everybody agree with that? Okay. Now in calculus, we're going to see something like this coming up. And when you flip through that P1 to P3 pages, you'll see something like this. It looks different. We're going to say substitute an x plus delta x. Now I know you might not necessarily know what this means, but one thing you should be able to tell is delta x is not the same as x. They're two different variables, right? And you're following what you did here. Hey, whatever I saw in here, if it was a 2, I substituted for x. If it's an a, I substituted for x. Now if it's this, I'm substituting for x. So your process hasn't changed at all. Yes, you get a different look. So here I'd have 3 x plus delta x minus 2. And yes, I can distribute the 3, but that's okay also. Does that make sense to everyone? Okay. All right, you then looked at it with more than one function. Let's give you, say, g of x is x squared minus 5. And an h of x is 2x plus 4. Make up two different ones there. So this is where you had to make a decision. What do you think h of 5 would be?
14.
14. 14. So we're going to put the 5 over the h function, right? So this was a mapping. You know you're substituting 5. This was telling you to go over here. So 14. So then what's g of 5? 20. Everybody agree with that?
Yeah.
All right, so again, it's that mapping telling us now to substitute it into G. Okay, now let's go a different look. Still function values, now just got A's going in. So we're going to take G of A and then subtract h of a from it. So the first thing would be to substitute the a's in, right? All right, so we'd have g of a squared minus 5, minus h of a, 2a plus 4. Everybody agree with that? And then if we can combine the 5 and the 4, distribute the negative, but something like a squared minus 2a minus 9. Everybody okay there? Okay, so get a little bit different look here. You should remember somewhere before seeing a piecewise function, where you just had a function broken in. It was usually either 2 or 3 parts. This one here, I've got 3 parts on it. Okay, I can still find function values. I want to find f of 7. All right, so then my thought process is, instead of looking at 2 different ones, sitting like a g and an h, now I'm looking at all of them together. But I still have to decide where the 7 goes. Am I going to substitute the 7 in the top, the middle, or the bottom one? Bottom, because it says greater than or equal to 4, right? All right, so 7 squared plus 2, 51. So you get a different look, but it's just having you make a decision there. Okay? So what about f of negative 4? Would it go in the top, middle, or bottom one? Top. Negative 4 is less than negative 3, right? So we're going to have negative 4 plus 1, negative 3. How about f of 2?
No. Top.
Oh, it's not, doesn't exist in our
Undefined.
It's undefined or doesn't exist, because it's sitting between, right? It's not between negative 3 and 1, and it's not greater than or equal to 4. Right? So what you're not used to a lot of times is having function values that don't exist. But you're still in the same process. Hey, where do I substitute that 2 at? Well, where I want to put it, there's nothing there. All right? So this would be what we call a discontinuous function. In other words, instead of connecting or picking up where it left off a complete domain, it breaks apart. Okay? So this we would say does not exist. Or we could say undefined or not defined. Any of those answers would be correct. Right? It's not part of the problem. Okay? How about if I said find f of 1? Why do you say it doesn't exist?
Because its x is less than 1 and not.
There we go. We don't have the equal to here. So it looks like at first like it might exist. But then wait a minute, there's no equal to, it doesn't. Does that make sense to everyone? Now, you should remember somewhere graphically, like if it doesn't have the equal to, and I'm drawing this part of the graph, remember how that's an open circle on the end?
Yeah.
Okay, it would be closed if it had the equal to. So I'm not quite getting to that one. I got to 0.99999, never hit the 1. Does that make sense? Okay. How about, what's f of negative 2?
3.
Does that one exist?
Yeah.
Yeah, and that was gonna stay a 3, right? There's no x to substitute. That just means it's that constant horizontal line. It's that constant function. It's always a 3. It's not gonna change anything. And how about f of 0? Also 3, right? Okay, so just to kind of give you an idea, for your calc stuff, okay, so taking what you learned before in the calculus. That's calculus. Pretty much mirrors what you did before though, right? Okay. Combining them, that's going to work with our calc stuff. Still mirroring kind of what I did before. Okay. And then pretty much all of this is, mainly these guys, knowing where a function exists and doesn't exist, but you're still doing the same thing you did before. Nothing changed. Okay? You're just substituting that value for x, so we're saying that these are the domains. When you put the value in, you get the range value, right? So you should be able to tie that back to. Remember how this was the point 2, 4? Put an x in. You got a y out. Okay. Even in a piecewise function, this is the point 751, the point -4, -3. There is no point. The graph doesn't exist there. You're still looking at it the same way. Different looks though. Okay. Most of what we'll do is going to tie back to something very basic that you did in the past. Something really basic. And then they just get uglier looks. It's still that same process. Okay? Alright, so your assignment is going to be